Hey everybody, welcome back to Tech Junior Tutorials. My name's Lee Warwick Jr. and we're talking about Advent of Code. Today's actually Christmas, so Merry Christmas. The final puzzle dropped today on day 25. It looks like a pretty neat one, but today we're going to be talking about day 20, which is another maze puzzle, so let's check that out. So here on the site, there is day 20. This one is another maze, like I said. Except now we're talking about donut mazes. So, long story short, you're going to have a maze with a hole in the middle. So that's where they get the donut name from. So what they say is these letters here are doorways or portals. So you're going to start at doorway AA at that point. Your goal is to get to ZZ at that point and find the shortest path from A to Z. The trick on this one is that you've got these doorways, so like BC, and that can loop over to here and like pop you out the other side. So if you go through BC, that takes you here, BE takes you there, FG takes you there to ZZ. And they say, I think it's a little bit shorter if you go through the portals and be 23 steps. They give you a couple larger ones. So this one they say is 654. So I used a lot of the code from day 18 for this one. I did a like a breadth first search, meaning I'm going to generate a path whenever I hit a fork. So like if I start here, I'm going to make a path for there, there, and there. And then the next iteration through, all three are going to do the same thing and look for a new path until they hit forks. And then that will generate another path. So I loop through all the paths each time and take a step. So every path that is generated from a fork will take one step at a time until they either hit a dead end, like right here, or they actually hit the exit, which is down here at, over here at ZZ. So looking at this right off the bat, first of all, the puzzle input is absolutely ginormous. So if we look at the puzzle input, there it is. Here's a huge hole in the middle. This is like way bigger than, at least it feels way bigger than day 18's maze. So that was a little troublesome right off the bat, kind of had me worried. I was able to get part one fairly quickly because, like I said, I reused a lot of code. So if we look at that real quick, scrolling back up here, that's on part two. So the step count that we're looking for is 654. This example up here is 58. What I've got in my code, if we look at this, is again a lot of the same stuff from day one. I'm sorry, day 18, the first massive maze that we had to do. I copied over a lot of the same methods or functions, like splitting points and storing them as strings and stuff like that. Still parsing the input the same way. The first thing that I do is loop over the input after I bring it in as an array of lines. And each line I treat as an iterable and iterate over the line and look for any hashtags, which means that's a wall. And then I add that to a set. Otherwise, I just make that a blank space. Kind of getting rid of all the dots that are on the map because I tend to use those in my visualizations for the paths that I'm displaying. Then I grab the height and width of the maze. I have a little helper method that I use for debugging just to print it to my console and make sure that everything looks good. And then this massive method here, which is like almost 100 lines, is where I'm parsing the puzzle or the portals on the puzzle. So if we look at a smaller example, too big. How about this one? Going line by line, I want to find every time I hit a letter. And then I want to, like, because these portals are on all different sides and inside and outside, all that stuff, I need to know if it's a vertical portal or if it's a horizontal portal. Then I need to know if it's an outside portal or an inside portal. Right, so there's a lot of logic that goes into that. And moreover, because these things are 2 letters plus the actual space, like I need to know where the letters are, which letter I've hit. Did I hit the first letter or the second letter? I need to know where this spot is because that's the actual pathfinding spot that I'm worried about. And I need to handle these portals like being basically on both sides. So I don't want to like parse this as a vertical portal and try and like have that spot. I definitely had that error at first where like I was pathfinding outside of the map because I didn't add these portal letters to anything. So it treated those as like a path that it could explore, which wasn't good. So basically what I do here is I say, okay, if I hit y equal to 0, so the very top of the maze, and I've hit a letter, that's going to be a vertical portal. And so I'm going to say that that XY point is going to be the first letter, and then the second letter should be down 1 from that, and the actual portal location should be 2 down from that. And then this other thing, the inside of the donut, basically when we're parsing this, going back to like this example, if I'm looking for the first letter being vertical on top, that is going to be the same logic as the inside of the donut here. So like, look, second letter is going to be +1, portal location is +2. But the way to check for that is a little bit harder than just saying like, oh, does y equal 0? I'm looking for y is greater than half of the height of the maze. So if it's in this bottom section here, then I know that it is a what is it? A bottom vertical portal. And there's some more logic to it. So if y is greater than the half of the maze height, and it's less than the maze height -2, meaning it's not on the outer edge, and x is between 1 and less than 2 of the maze, that should be width, actually. I think I got lucky on that working out. Yeah, that should be, yep. So that's actually lucky that that worked, because this should be width, I'm pretty sure. So we're talking about x and width. This should also be width. I tell you, trying to do these puzzles is tough. Okay. And hopefully I didn't break anything doing that. Let's run this with the input. Okay, so thankfully still good there. I think I need to probably change that over here then as well. Did I actually, I refactored this a little bit whenever I wrote this again. So exit maze, yep, that needs to be width. I had to change this a little bit in round 2 or part 2. Maze width. Height width. Height width. So x is only concerned with the width, y with the height. And then we'll try and run part 2 real quick and just see how long it takes. A long time. It takes like 30 seconds to go over and find the paths for part 2, but we'll get to that and explain why in a second here. But basically, yeah. So I'm splitting these up into quadrants and then kind of mapping them by the locations. Meaning, so like if this, so there we go. There's the answer for part 2. For the top portals, those are going to be the same logic as the bottom inside vertical, and then like the right, or I'm sorry, the left, be the same as the right inside because they're left to right, top to bottom, top to bottom. This left inside will be the same as right outside because the point's going to be to the left, so on and so forth. So it's just a ton of logic that basically is looking at that and splitting things up into basically the upper half or lower half, or left half, right half, and not on the outer edges. So tons of logic for that. I don't really want to spend too much more time talking about that. Then I say like, hey, if there is a second portal letter that I've saved and it's not like none, this is kind of just like a sanity check for me. Same thing with this down here. I take the ASCII letter and or grab the second portal letter, and if it's anything except for a actual A through Z letter, I'm going to return, and then I'm going to assert. So I really didn't want to have any errors like that, so I just threw a bunch of code in there to make sure that that didn't happen. And then here, I've got some code that down here prints all this information out with like where the portals are, just to make sure that I parsed everything correctly. So I've got this maze function, and that's what I use for visualizations. I loop through and call, loop through again and call add portal every time I hit a letter. Add all that to some dictionaries. But up here, I end up storing a lot of stuff. So I store the portals by name. So like AA, or not AA, because that's entrance and exit. So AA and ZZ I handle differently. I store those in their own variables. But for everything else, I put it in a portal dictionary by name. So that's like BC, points go into BC, and then UG would go to UG, so on and so forth. From there, I actually parse that dictionary, and I make one dictionary that just doesn't care about the letters, and it connects end to end. So like if it goes through and it sees like, let's say this point, it's going to look at first like, okay, here's BC, and it comes with that point and this point over here. So it's going to add an entry that's like the key is that string, the value is that string, and then it's going to make another entry where the key is this string and the value is that string, so that whenever I do a lookup later, and I'm like, oh, I've reached this point, I need to travel, I just take that point and look it up in the dictionary, and it gives me the other point where I come out at, which is really simplified this a lot doing it that way. So from there, there's a couple other things I do. Somewhere in here I add, yeah. So I have a portal letters set, and that I basically treat kind of like walls, where if you hit one of these portal letter points, treat it as a wall because you're never supposed to walk over those. So like I should never be in the middle of this map or outside of the map. And I just went ahead and added the outer letters too, just in case, because if you notice, like the second letter is actually the wall that you would hit here, but on this one, it would be the first letter that you would hit. So I just added both. Okay, so that's a lot of the logic that I did. And then you can see how I did that. I call print maze. Hopefully that still works. So if we do, whoop, actually not going to work for the first one. Let's use one of these smaller mazes real quick. Still not working because I think I have this commented here. So I have this code that just adds in like @ symbols. Well, we don't need to talk about that. So, okay, so when this runs, this is just my debugging stuff to parse the maze. If I've put an @ symbol everywhere on the map, we're basically plugging the holes around this donut, then I know that I parsed everything correctly. So I made sure to do that first and then move on to the actual pathfinding. So that was really important. And that we can remove, and we can remove that. So once I've got all that information, so I've got the actual maze, which I use for visualizing. I've got a set of all the walls. I know where all the portal letters are. I know the portals, how they connect, so what point connects to what point. from there, I actually ported over my MazeBot class, which I don't really use a lot of the class stuff in this. The paths part I just use for visualization. Position I don't even really use. So I've got my get surrounding coordinates, except I've added a little bit to it. So this, if you wanted to know a little bit more about this, I started using this get surrounding chords function in day 15, I think. And then I ported it over to day 18, and now I'm using it again for day 20. And I think that's going to be the last time we do a maze for Advent of Code, thankfully. But basically what this does is it looks in all four directions, so up, down, left, right, around whatever point it's given. It returns back a bunch of possible points that you could go in. So it gives you what directions are paths that you've already traveled, what directions are walls, and what's unexplored directions. And then I added in here a little thing that says, okay, first, if you've touched a portal letter, like that is a wall. Second, if your position is in the portal dictionary, you can add that portal exit to one of the unexplored directions if you haven't already been there. So that lets me loop like in and out of all these portals. From there, I've got a print method, my find exit method, which is very similar to my find paths or get keys or whatever from day 18. So this loops over, like I said earlier, it goes through every point. So if I start up here, my next possible would be here. So that's only one path. And then it's going to create 3 new paths, and it's going to go out in each direction from there. So when we run this, you'll see a little visualization of it. So I got to actually turn this back on. So you can see it's kind of like, it's kind of spreading outward from here. And you can see like it didn't even get to check some of these points because it hit ZZ faster. So you'll see like it goes through AS, and then it's going to come out this side. That's going to come through here. Eventually, like they come through on JO. So it's over. So it looks like it starts up top, comes over here, comes out the bottom, and then finally like one of the paths hits the exit at ZZ, and then it stops. This is the second example, which is 58 steps, which I used this one right here, right there. So I knew that I was in good shape from that. But yeah, like I said, it just loops over all the possible paths until it hits a coordinate from the last position in one of the paths that was the goal, basically, and then it returns the length of that list of coordinates, which is how many steps it took to get there. And then this part here is just for visualization. So it says like, hey, if we're not looking at the main puzzle input, which is too big to really visualize, go ahead and print it. So if we change this back to input and run this, see it runs in like a second. That is our answer 654 from here. So not too bad. I managed to get that pretty quickly. But for part 2, this was really scary when I read it. For part 2, they say that the portals aren't connecting to themselves. They're connecting to another copy of the maze. So that was like scary. They say that this is a recursive maze. And the way to really just explain this very, very quickly is if we're looking at this example here, they say that in the donut here, it's not empty space. It's actually a smaller copy of the same maze. So what that means is here is a smaller copy right there. So if you go in, let's say QG right there, that is going to pop you out right there on this smaller maze, and this is all unexplored. So they say the outermost one, like level 0, or the top level, the biggest maze, is the one that you're starting in. And it says treat all the outside portals as walls, and treat all the inside portals as portals that go to the outside of the inner maze. So this QG right here, that one right there, is going to link to this one right here on the inner one. And if you keep going smaller and smaller, you can go like an infinite amount of levels deep. So that's bad, especially for the algorithm that I wrote, because you're going to have paths that are going deeper and deeper and deeper and never stop. And it's kind of like a rush to hit that exit before the data that I'm tracking gets too big. So what I ended up doing for this was I abandoned printing it and visualizing it. I just said like, okay, I've got something that works for part 1, so I know like all that logic is correct. But now I needed to add basically what floor I'm on or what level. So they give you another little maze like this for a test input, thankfully. So they walk through like one possible path and say that 396 is the shortest path. The actual input answer is 7360. So for part 2, what I've done is, first of all, I refactored a little bit of my portal logic. Just said like, hey, if I'm basically stored the logic for if you're at the outer or inner portal or whatever into variables. So I could say like, if you're at top or bottom, do all this stuff. And the reason for that is I wanted to split this into outer and inner portals and store like which one I was at, because I wanted to know which portal I had hit. If you're going inner, you need to go one level deeper. If you're going outer, you go one level less. And so you're starting at 0, and like level 1 would be one smaller puzzle or one smaller maze. Level 2 would be a even smaller maze that fits inside of that maze. So first I did that. I deleted all of my logic for printing or visualizing anything in the terminal. I modified its surrounding chords and all of my helper functions to take an X, a Y, and a level coordinate. So now it's like a 3-dimensional plane that I'm working on. So it's going to give the X, Y, and Z basically. So then I've got some extra logic for the possible positions that you can go in or directions. So like, okay, if you're at a portal and you're at level 0, you cannot go further out. That is a wall. Otherwise, you can go further in. There was a, actually this, I believe, find exit is mostly the same. So for find exit, the only thing that is different is I am making a new, I made a couple of helper functions. So I've got like make, point, and level. And what that does is it handles 3 parameters instead of 2. So I have some helper functions that I've been using for a while. I made a couple new ones. One that tracks X, Y, and level, and then one that splits VS Code. One that splits this pipe and comma separated value. So it splits the comma, then it splits the pipe. And so with that, I used a combination of both, which was a little bit confusing. I had to debug that a lot, make sure I got everything right. So first I had to start out on level 0, and then from there split, get my current level, get my current XY coord, get the next coordinate, and And then down here, I say like if I'm at the exit location and I'm at level 0, that's Yahtzee basically. I've got the path that I want. Otherwise, the most of this is the same, except for creating new paths and stuff using those other helper methods. The critical thing on this one was this piece right here. So here I'm saying like in my unexplored directions, basically, if I'm starting at 0, I can go like an infinite amount of levels deep, but because my algorithm is basically a breadth first search, where I'm creating like a new path every time I fork, one of those paths is going to continue to go deeper and deeper, and that's going to like exponentially create more and more and more different possibilities, and that is going to slow down this algorithm a lot. So basically, I was able to run the first example, which I've saved in 4. So that is this one here, right here. And that is 396. We need part 2. That pops up 396 right away. It didn't matter if I used this or not for that. It hit the exit relatively quickly. So I think we can even prove that. So a little bit slower there, but the real proof in the pudding is you do this. So if I print how many paths that it's generating on each iteration through, or how many paths it has to loop through basically for each total step, right? If we do that, you'll see it climbs up, and it kind of like fluctuates up and down a little bit. Goes up and down and up, and then it hits the answer. But if we do this for the real input, that's where things get interesting. So you see it's just like running and running and running. It's going progressively bigger. And it's slowing down. So now you can see it's starting to creep a little bit as it gets up into the 200s. And this is the amount of possible paths that you could take at any given point. Basically the number of directions that are taking a step on each loop through the while loop that I have. So now it's up into the 300, 400s and getting slower and slower. Basically this would never finish. So we actually, where was that? Right there. What I had stumbled on reading the Reddit looking for like clues and hints and stuff was one fellow that jumped in and said like, oh, I realized, to optimize this, because when you read the Reddit thread, it's like, oh, I got this in 2 milliseconds or something. I wrote it in C or some madness. One guy said, I wrote an optimization that it basically doesn't let you go deeper than the amount of portals. So for each basically level, like he limited the levels that you could go down, which I tried to do also. But if you stop it at the amount of portals for levels, so like if you have 16 portals, only go 16 levels deep. Basically what it's doing is if you go through every portal, so if you go through, here I've got the inner portals, right? So that's one set of portals. If you go through every portal at least one time, you've looped the entire maze, basically. So if you limit it to less than that, it prevents it from going infinitely deeper and deeper into the maze. You can only go however many levels deep as there are portals. And when you do that, you can see when you run this, no longer is it creeping up to like 100, 200, 300, 400. It's staying around like 20 or 30 different paths. So it's like going in and out of portals, up and down levels. It still takes a while for it to run. It's a lot of possible paths for it to go through and a lot of steps to get there because it's like 7,000 steps. So what it's doing is it's like hitting dead ends over and over again. And whenever it hits a dead end, it drops that path. So it's no longer tracking that. But yeah, eventually you'll hit 7360, which is the number we were looking for. So where was that? I don't want to print the... There we go. Don't want to print the paths whenever I run this. So that's all I've got for day 20. Day 20 was really tough. Not as tough as day 21, which I'm about to record a video for. But I feel like all the maze stuff that we've done up to this point has like prepared and laid a lot of groundwork for day 20. So like if you were able to do day 18, then this is not as bad. And I definitely felt that. 18, looking back on that video, was like really rambly and long, and I think I was super burned out from doing that puzzle, so that was really tough to do. But for this one, it seemed pretty straightforward because I already knew how to solve a maze, and the possible key directions that you could do was like already a really super hard problem. I heard somebody or read somebody on Reddit that had solved this one by calculating the distance between each portal and using the same type of algorithm as the key problem to find out what combination of portals you could take to get to the exit. So that was an interesting solution. That prevents my whole pathfinding algorithm. You could just like let it go and let it run and run and run and run and run. And that would speed it up a whole lot. But I was really hoping that I didn't have to do that because I already wrote like a ton of code to get this far. And I even thought at one point, like, man, is this like a cyclic maze where you could loop back over the same points, like go down a level, walk around, come back up to the top level, traverse the same path, and then finally get to the answer. Thankfully, that was not the case. Otherwise, this algorithm would have been super duper tough. So that was good. Yeah, so that's all I've got for day 20. 21 I was able to complete. 22 is super tough. We'll talk about that one, hopefully, if I complete it. But the scatter plot for the top 100 people. So if we look at that real quick. This is day 18, this tall one, and the one that's taller than that is day 22, part 2, so I'm going to try and work on that one tonight. Here is day 20, so about half as hard as 18. I think because, like I said, everybody had been already working on all the mazes and stuff. 21 was a super difficult one for me because it just took so much like cognitive overload to process that. And then 22 is like dealing with a deck of cards problem. So that's going to be interesting. But yeah, 21 was pretty fun once I actually got it. So check out that video coming up after this one. All right, let me know how you're doing in the comments. Like, subscribe, review, whatever. Hit me up on Twitter at LeeWark Jr. Let me know how it's going. Hopefully you're keeping pace or you've already finished Advent of Code. I saw a lot of tweets go out today for that. These are super duper hard, so if you got any of them, like pat yourself on the back. They are difficult, and you are a bad mamma jamma if you're able to solve any of them. So with that being said, I will see you on the next one.